So let me revise the separate equations. Separate equations of ax square plus 2hxy plus by square is equal to 0 are given by ax plus y of h plus root of h square minus ab is equal to 0 and ax plus y times h minus root of h square minus ab is equal to 0. This is important point. And next important point is, if h square minus ab greater than 0, then these two, that means they represent two distinct or different real lines. So next point, if h square minus ab equals to 0, then they represent two coincident lines. Suppose if h square minus ab less than 0, then they represent two imaginary, not real, imaginary lines, but they pass through a real point, that is origin. Okay. So now, this is the just what we have studied in the earlier episode. So just we recalled. So for the sake of any competitive entrance examination, these 3 points are very, very important. Even this is also very, very useful to find out the individual equations as separate equations of ax square plus 2hxy plus by square is equal to 0. So now let us find out the sum of the slopes of the lines or product of the slopes of the lines represented by ax square plus 2hxy plus by square is equal to 0. So let us find out now. So now to find sum of the slopes, sum and product, let us find out sum and product of the slopes of lines represented by ax square plus 2hxy plus by square is equal to 0. Now how to find out. So how it is to be formulated. So that means we need to develop the formula to find out sum of the slopes of the lines and product of the slopes of the lines. That means we need to deduce the formulae. So for the sake, so we know that in the earlier theorem, we know that this represents two lines which pass through the origin. So that means let us consider one of the lines as y is equal to mx. The y is equal to mx should satisfy this equation. Am I correct now? So that means now suppose the y is equal to mx be the one of the lines. You need not get any confusion because they represent two lines which passes through the origin. The general form of the line which passes through the origin is nothing but y is equal to mx. So now in the place of y replace mx. So in the above equation, from above equation we get as follows. We get ax square plus 2hx of mx plus b of mx whole square is equal to 0. So providing here m does not equal to 0 only here. So this we can write now ax square plus 2hmx square plus b of m square x square equal to 0. Just check the step. So throughout from left hand side take out x square common. This we can write bm square plus 2hm plus a equals to 0. X never be 0. So since x does not equal to 0, x square also does not equal to 0. So we get bm square plus 2hm plus a is equal to 0. Here also one technique we can follow. This can be obtained directly. Whenever you say y is equal to mx, wherever x put 1, wherever y you put m. See what do you get? Here put x is equal to 1 and y is equal to m. What do we get? bm square plus 2hm plus a equals to 0. This will be useful for entrance examinations. So directly we got this one. So now what does the bm square plus 2hm plus a is equal to 0 represent? It represents a quadratic equation in m. So being a quadratic equation, it possesses two roots. Let us say one is m1 and m2. m1 be the slope of the first line, whereas m2 be the slope of the second line. So we need to find out sum of the slopes, that is nothing but sum of the roots of this quadratic equation. So the sum of the roots of the quadratic equation easily you can find out. So in the similar pattern, in the similar manner, the product of the slopes means m1 into m2, that is nothing but product of the roots of this quadratic equation. That also very simple manner we can find out sum and product of the slopes of the lines which represents ax square plus 2hxy plus by square is equal to 0. So let us proceed now. Since it represents a quadratic equation in M. Say m1 and m2 be the roots. So now let us find out sum of the roots, that is m1 plus m2. So regarding to this quadratic equation, we need to say that minus coefficient of m divided by coefficient of m square. So obviously the m coefficient is 2h, we get minus 2h by b. So whereas the product of the product of the roots m1 into m2 is equal to constant term upon or divided by coefficient of m square. So that is nothing but a by b. But regarding to the quadratic equation, m1 and m2 are the roots, but whereas as far as this pair of straight line concerned, they represent the slopes of the two different lines. That's why this is nothing but sum of the slopes, this is nothing but product of the slopes. So hence we conclude that sum of the slopes so that is m1 plus m2 is equal to minus 2h by b. So better remember, product of the slopes equal to m1 into m2 is equal to a by b. So this is very, very important. I hope you might have followed.